Hi, this is a brief presentation regarding addressing non-normal data. And what do I mean by non-normal data? I mean data that has been violated, the assumption of normality, either by the Shapiro-Wilks test of normality or the Kolmogorov-Smirnov test of normality. Basically, in the Unit 1 scaffolding video, we examined some data that had some skew. I believe it was a pretty substantial positive skew. And in that case, we did a log of the data or the variable that was skewed to attempt to transform the data into a more normal looking distribution. And then you retest it using the Shapiro-Wilks or Kolmogorov-Smirnov test of normality. So, how did I know how to do a log of that variable? How did I know? There's a book called Mertler and Vanada's Advanced and Multivariate Statistical Methods that provides a look into the different common data transformations, which you have here. I've reproduced this table from Mertler and Vanada 2010. And he gives you the different transformations that you should consider in doing, depending on what kind of skew you have, positive, and then the degree of positive or negative, and then the degree of skew, whether it's moderate, substantial, or severe. So this is the original table from Mertler and Vanada, and it has the original shape of the distribution, the transformation that you can make, which is square root, logarithm, inverse, reflect and square root, and then reflect and inverse, and then the actual SPSS compute language. Now, in our class, we're using the R software, so I've modified it to make a modification to these data transformations to provide it via R commander language. And so I've highlighted in red how it's different from the SPSS language, which is just really that you actually write the word log rather than log base 10, which the default for log is a base 10, so it's kind of superfluous characters there in the SPSS command. So the R command language is much more succinct, I think. So basically, if you want to create if you have data with a moderate positive skew, the transformation would be square root, and then so you call it whatever you want. In this case, we're just calling it new x, the new version of x. And so you do square root of that variable, whatever x may be. And then it goes on you can do a log of x for a substantial positive skew, and then a log of x plus c. And so what is c? If you look at the notation for A, it's a constant added to each score in order to bring the smallest value to 1. So what does that mean? Usually, it means if the minimum value for x is less than 1, then you need to add 1 plus that value. So if the minimum value is 0 for that variable, then you need to add at least a value of 1. So the constant would be c. If the minimum value was -1, then your minimum value needs to be 2, because -1 plus 2 is 1. So then that would give you the smallest value of it being at least 1. So then you have the value. You can use c a couple more times, that whatever this constant may be for your data set. So you need to determine, well, what is the minimum value for my data set? And if the minimum value is 1 or above, you're okay. Don't need to worry about it. But if your minimum value is less than 1, then you need to add some constant so that your new minimum value is at least the value of 1. So next we have k. So for moderate negative skew, you reflect in square root. So square root of k minus x. And then you see the b notation to explain what k is. K equals a constant from each score is subtracted so that the smallest score equals 1. So the smallest score equals 1. So what that means is that you usually take the largest score, or the max of x, plus 1. So the maximum score in the distribution is, say, 10 max x equals 10, then you add 10 plus 1, which will give you your K constant. So basically saying that a constant from which each score is subtracted so that the small score equals 1. So that would mean that this new K of 11 minus 10, because 10 is the max score, would then give you 1. So this has been a brief presentation regarding the different data transformations you can do depending upon the kind of skew you can have and the degree of skew you have within your data set. So just go ahead and run your Shapiro-Wilks and Kolmogorov-Smirnov test. See if your assumption normality is violated. Once it's violated, look at your histogram. Look at a histogram of how the data is distributed. And then once you've looked at how it's distributed, then you can determine, well, is that a moderate amount of skew, a substantial amount, severe amount, etc., etc. And then you can make the correct or the most accurate transformation for your data to hopefully it'll become more normal. Then after you create this new variable that's hopefully more normal in this distribution, then you can test again the Shapiro-Wilks and Kolmogorov-Smirnov on this newly transformed variable, and hopefully it will be more normal, and usually it is. So, okay, well, thanks and good luck.